600 milliosmol and live in freshwater, it's going to go to the lowest level it can sustain, and so it might be around 100. Whereas in marine, it's not going to try and keep it at 100. It might osmoregulate, but it might be up there at 600. So it might osmoregulate. It won't be exactly what's the concentration of the two extreme environments, but it'll be closer than the two species of one genus will be closer to whatever environment they're in. Now, you can still be an osmoconformer and have different concentrations. Osmoconformer will say, okay, I'm living in 1,000 milliosmoles, so my milliosmol level in my body is going to be 1,000. But it could vary a little bit in, well, I got a little more sodium, or I got a little more potassium. The contents still add up to 1,000. Because it's really what matters as far as osmosis goes is what's the level. What matters in terms of sometimes metabolism is what concentrations do I have of magnesium. And so say the level of magnesiums could be different in the organism compared to its environment, even though its overall osmolality is the same as its environment. Okay, there's some guys, like salmon, that spend half their lives in salt water and half their lives in fresh water, so they have to deal with wide extremes of environments, and that's rare. Most organisms can tolerate only small differences in changes in their lives in time. So they usually live in environments that could be fresh water, could be salt water, but they're not going to go back and forth from salt to fresh very easily. And so they're not adapted very well, but the salmon are. The king is tilapia. It can live in environments that vary all the way from 200, or from fresh water, which is probably the 15 to 40, to 2,000, which is twice regular seawater. Because there's some places, the Dead Sea, and some places in inland seas that evaporate, and they don't have an outlet. All the water comes into the sea, comes into the lake, and there's no outlet to the oceans. And in those cases, sometimes when it really starts to dry, then a lot of salts and stuff just stay in the environment. And the Great Salt Lake is an example. Mono Lake in California is another example of these inland lakes that can get very salty and can vary from being salty to not so salty depending on rainfall. Do you have a question?
Sure, I'd like more geologic.
Okay. Well, you can talk to me about that. I'll see if I can answer it. Okay, so it's kind of interesting that, so you've got fish that have to osmoregulate, but they've got a problem in salt water of losing water to the environment. In fresh water, they've got a problem of too much water coming in. Remember, animals don't have cell walls, so they can explode if they get too much water coming in. So we don't see exploding freshwater fish, so they must be doing something about it. So you got to think, okay, here's, in this case, a saltwater fish. It's going to have trouble losing water to the environment. So it's got to take in some water, and then it's got to desalinate the water to some degree. So it's taking in the water, and kidneys are okay, but fish don't have the greatest kidneys in the world. We'll see again, like most things, the birds and the mammals seem to have the most efficient kidneys. Fish don't have the best kidneys in the world, but it's not bad. but they actually use their gills to get rid of a lot of the NaCl. So a lot of the ions, especially NaCl, which is dominant in salt water, they get rid of the NaCl, so they take in a fair amount of water and get rid of it through their gills, and also a bit in their kidneys. Now freshwater fish have the exact opposite problem. They don't need to take in any water. So they take in very little water, mostly in their food, but they have a problem of getting ions. So they actually, their gills work in kind of reverse to the salt water. They actually actively take up sodium and chloride, as well as some others. So they're trying to think of it, okay, they're in fresh water, so water's coming in, but that fresh water has very few dissolved substances, and they need dissolved substances. So they're gonna take in some of those through the surface of their gills, and when they excrete, they're gonna excrete large amounts of very dilute urine. They don't wanna get rid of their ions that they've so carefully extracted from the environment and maybe gotten in from food. So they need to get rid of water. They're going to get rid of very dilute water. And so they're just by having gill openings and things like that, they're going to take in a lot of water just in their body, even if they don't drink. So they'll take in a fair amount, so they've got to get rid of it through dilute urine. And we'll continue next time to discuss kidney